afternoon. Is the microphone working?
Yes.
It is, yes. Good. I picked up the wrong one, so I was in risk of being on the wrong band. Thank you for the opportunity to be in Malvern. It is actually my first visit here, having admired the hills from a distance many, many times and always intended to come. And thank you for arranging some sunshine as well. On my title slide, I have shown, as a symbolic gesture, both my Quaker affiliation, Britain Yearly Meeting, and my academic affiliation, University of Oxford. Eric was talking about solar eclipses, and he was also talking about different ways of describing things. So I felt slightly mischievous and inserted a couple of extra slides. These concern eclipses of the moon. You see a picture of the moon in the bottom right-hand corner, and every so often the moon slips into the Earth's shadow, and you see, just as we saw with the solar eclipses, the disk of the moon gradually disappearing. Sometimes the eclipses are partial, but sometimes they're total. Some Pacific Islanders describe total eclipses of the moon in the following way. So, I am Quaker, as you've already heard. I've been Quaker all my life. I was born into it and I've remained active the whole of my life. I've been a scientist from about as long as I could be. It turned out I was good at physics as soon as we started doing it in secondary school. And thanks to that and the Soviets launching the Sputnik satellite, which scared the US and the UK enormously, because we thought we were in advance of the Soviets, but we couldn't launch a satellite, led to a great emphasis on science in the UK, and anybody who could even half do science was encouraged to do so. So I was in my mid-teens by that point, and further pressure to be a scientist. It was also about my mid-teens that I became clear that if I could, I would like to be an astronomer. That was the bit of physics that really interested me, excited me. And I've been lucky enough to work in astronomy for most of my professional life, in or around astronomy. So both my astronomy and my Quakerism have kind of grown up together. And I describe them as being comfortable bedfellows. But right at the end of the talk, I'll just look a little bit again at these bedfellows as Bedfellows. I hope I don't send anybody away into a serious fit of depression or seriously troubled in their beliefs. I am not trying to convert you, I am trying to give an account of where I am. And I think that's the only thing one can do. I also want to stress, in case you haven't already discovered, that Quakers are a very heterogeneous group, and no one person can speak for all Quakers. I am speaking for myself, but it is out of a Quaker upbringing, a Quaker background. And another warning is, I'm trained as a scientist. I'm not a professional theologian, although I have interest in it. I am not a professional philosopher, because I just can't handle it. And I'm not a sociologist, although there are times when I wish I was. And to really do this kind of talk properly, you probably need all those, plus psychology and a few more things as well. Neurobiology these days probably as well. But I'm speaking as a scientist. I'm going to build on Chris Lintop's talk. He talked about the history of the universe and the future of the universe. I'm going to give you a little bit more astronomy because stars are relevant to human life, so I say a bit about that. I'm going to talk a lot about the prospects for humanity in the light of what we've heard this afternoon, I'm going to say a bit about what this says about God, the theology. Quakers, don't run away. But I'm also going to try and talk a bit about what I describe as the heart stuff, if the theology is the head stuff. The picture is a picture of the Milky Way done by an contemporary Australian Aboriginal painter. And it's done in the dot painting that they do in Australia. It's interesting because Australia is also on the globe, and therefore they have much the same view of the Milky Way as we have in Britain. And that is not our view of the Milky Way. Our view of the Milky Way is as a band across the sky. Somebody has shown him a photograph of another galaxy and says, the Milky Way would be looking like that if we could get outside it. And that's what he's painted. But I love it as a painting. It gives a great sense of the rotation of the galaxy and the spiral structure. So, the kind of stuff we're talking about this afternoon covers an enormous time span, looking billions of years back and probably billions of years ahead. And it's awfully tempting for those who aren't theologically inclined to say, well, it doesn't matter. Forget it. Don't listen. I argue that actually this hugely impinges on our theology, on our understanding of God, on our picture of God. And therefore I think it's important that we have at least some understanding of the past billions of years of the universe and the future billions of years of the universe, because that affects, I believe, our picture of God. And what I'm primarily going to be talking about is our picture of God, given the information I have as an astronomer. But first a little bit about stars. It's already been alluded to. Stars are born, they live, they die. They take a lot longer over it than we do, so to any one of us they appear unchanging, but they're not. The sun is about 5 billion years old. It's got about another 5 billion years to go. It's actually a relatively recent star, a Johnny-come-lately, and it has to be if it's going to be our star. Earlier stars would not have permitted life, and I'll explain that a bit more in a moment. Or as Chris put it, the universe is now past its best. Our sun is one of the stars in a universe that's mature, getting on. Stars shine because in their cores they're nuclear reactors. They're nuclear fusion reactors. Most stars are fusing hydrogen to make helium, and there's a bit of energy left over, and that energy comes out as the sun's light and heat. We are dependent on the sun for our life, ultimately. We need that energy supply. So we are dependent in our life on a nuclear fusion reactor. Admittedly, it's 96 million miles away, which puts it at a fairly safe distance, but Quakers and anybody else so inclined, you cannot declare the solar system to be a nuclear-free zone. It ain't. Sun uses up 600 million tons of hydrogen every second. And as I said, it's been doing that for 5 billion years. And we reckon there's enough hydrogen in the centre of the core of the sun for it to continue doing that for another 5 billion years. But it's a huge rate of consumption. But then it's quite a huge thing. The thing that I particularly want to stress is that in our bodies, well, we're 2/3 water. Can anybody tell me the chemical formula of water? H2O, hydrogen and oxygen. Chris mentioned hydrogen created at the time of the Big Bang, along with helium. The oxygen wasn't. Nor was the calcium that's in your bones. Nor was the carbon that's in your tissues. Nor was the iron that's in your bloodstream. Those chemical elements, those diversity of chemical elements that permit life, they were created inside stars. Well, they're not much use to us inside stars. They're a bit inaccessible. But they were made available to us by the explosive death of stars, which spewed the stuff out through space. And broadly what has happened is, over here, in one corner of the galaxy, a big star formed, 10, 20 times the mass of the Sun, went through its hydrogen burning phase, burnt helium, made carbon, nitrogen, oxygen, calcium, iron, exploded. Supernova, again Chris mentioned these. Supernova spread the stuff out through space. And some of this carbon, nitrogen, calcium, iron spread over here to where another big star was forming. And this big star went through its life cycle. It fused hydrogen to make helium, made carbon, made calcium, made iron, made oxygen, and at the end of its life exploded. And the products from this star fanned out through space. Now the products from this star contain the carbon, the oxygen, the iron and so on that was made inside the star, plus the stuff that joined it from over there. So the stuff that carries on is doubly enriched in carbon, oxygen and so on. And some of it spreads over here to where another star is forming, and this is the Sun. And the Sun is made with what was here, plus the products of two previous generations of stars. And the Sun forms, some of the material is left over. And the material that's left over is in a disk and ultimately makes the planets, including Earth. And Earth is therefore made of the same stuff as the Sun. It's made of stuff from previous stellar cycles. Sun is a third generation star. And only by being a third generation star is there enough calcium, oxygen, iron, etc. on this planet to enable life. The other stars may or may not have had planets, but they won't have had the richness of carbon and so on to make life. So we're the daughter of a third generation star, and it has to be a third generation star. It has to be a Johnny come lately, because earlier generations would not have permitted life. So, yep, we're products of nuclear reactions, nuclear waste if you like, or we're fantastic creations, or we're late stage products of evolution in a universe that's past its prime. You can take your pick. They're all true. This is an example of a supernova. The supernova is the bright dot at the bottom left, and you can see it's virtually as bright as the whole galaxy. These are incredibly bright things. That one's just 50 million light years away. The light year is about 10 million kilometers. It's local, relatively. But you can certainly see them at great distances. There was a famous astrophysicist called Eddington, who was also a Quaker. He died when I was about 1, and I hadn't made it to Cambridge by then, so I never got to meet him. But I've regarded him as an important person in Quakerism and in astrophysics. And Eddington did a lot of presentation of astronomy to all sorts of publics. And he came up with the multiplication table. I've censored the first couple of lines of it because it's plain wrong, but the next 2 lines are more or less right, and they're very useful rules of thumb. It says that 100,000 million stars equals 1 galaxy, and then he went on, 100,000 billion galaxies equals 1 universe. You have to modify that slightly now to say equals 1 nearby part of the universe. But it gives you a feel for the kind of numbers we're dealing with. Or put differently, there are a lot of stars in the universe. Now, you've got the idea that the universe is expanding, that the expansion has no centre. All those cubes in Chris's rods and cubes picture, any one of them sees the same thing. Any one of them sees all the universe moving away from it. But it is not actually the centre of the universe. It's because space is stretching all around it in all directions. And the Big Bang initially was very hot, lots of radiation, and as the universe has expanded, it has cooled. Everything's got more spaced out. So the universe we live in is cool, dark, empty by and large, and getting cooler and darker and emptier. And it doesn't have a centre, doesn't have a focus. One bit of it we judge as much the same as another bit of it, as far as we can tell. It doesn't seem to need us, and I'm going to show you that it will kill us. And it seems amoral, purposeless, maybe even meaningless. A bit disturbing. I love poetry, as some of you know, and I'm going to read you a little bit of a poem written by Lord Byron. It's called Darkness, and it was written in 1816. 1816 was known as the year without a summer. The weather was really terrible. I don't think any of us have experienced anything as bad as that. You know, there was famine because crops weren't ripening. There were icebergs in the South Atlantic and this kind of thing. And they didn't know what was going on, and they rather feared it might be the end of the world. They didn't know why, but they rather feared it was the end of the world. And Byron has written this really rather revolting poem about the end of the world. I'm only going to read you kind of the first verse and the last verse, the first 8 lines and the last 8 lines, because they're astronomically extremely interesting. The middle bit, if you're feeling brave, is about what happens when the chips are done and it is the end of the world, and dog eats dog and man eats dog and dog eats man. And it's pretty revolting, but I won't read you those bits. They weren't at all sure what was happening. They wondered if it was due to some big sunspots on the sun, but actually it wasn't. It was due to volcanic ash. There had been a number of volcanoes in the previous few years which had put up a fair amount of volcanic ash. And that spring there was a particularly big explosion of a volcano called Tambora in what they called the Dutch East Indies, which put up a lot of volcanic ash. And that basically screened the sunlight and gave Europe and USA, or Northern Hemisphere, a very bad summer. And they probably gave the Southern Hemisphere a very bad winter. So Byron's Darkness. I had a dream, which was not all a dream. The bright sun was extinguished, and the stars did wander darkling in the eternal space, rayless and pathless, and the icy earth swung blind and blackening in the moonless air. And then right at the end. The waves were dead, the tides were in their grave. The moon, their mistress, had expired before. The winds were withered in the stagnant air, and the clouds perished. Darkness had no need or aid from them. She was the universe. And that's an eerily good description of the long-term future of the universe. The expansion of the universe, the increasingly rapid expansion of the universe, causes more and more galaxies to disappear over a horizon. Our skies become emptier. Old stars go out and no new stars light because so much hydrogen has been turned into calcium and carbon and iron and oxygen. The galaxies go black. The black holes have a field day. And yes, the little ones will evaporate. The big ones may in a very, very long scale. But the prospects for humanity are poor. And I don't think I'm being unduly sensationalist. It's not happening tomorrow. It's not happening in our lifetime. Well, I hope it's not. I'm talking very, very long term. And I did warn you that I was talking long term. But I think the long-term future of the universe is black, and therefore the long-term future for humanity is black. As I said earlier, we are dependent on the sun for life. The sun will expire in 5 or 6 billion years. Now, we may well have killed ourselves off before that, but let's assume we've managed to avoid that. So our sun goes out. Well, there are lots of other stars, and by this stage we are pretty clever, so we could climb into spaceships and go and find another planet around another star, preferably uninhabited, and go live there. But that star will die, so go live there, and that star will die. Ultimately, I think it's curtains, because there isn't a star, a live star, for us to live on, so to speak. The stars go out, and no new stars light. So I think the outlook for humanity is really pretty serious. So what does all this tell us about our picture of God? We're told that God created the universe and made us in God's likeness. Which brings me to a very awkward question. What is God playing at? Why does God create all this magnificent stuff only to have it wipe itself out? Actually, this question has been with us rather longer and doesn't seem to have been discussed. We've known for some time that species here on Earth last typically for a few billion years, and then evolution moves things on and those species die out. Did we not assume ever that would happen to Earth? Sorry, to us? Was our intelligence somehow going to prevent evolution from exterminating human life? I don't know. But I'm aware that the question I raise here is actually not that new. I just haven't heard it faced. So, a question that I've had to face is, how important is it that the universe is created by God? Does God have to be a creator God? Because that creates problems, at least for me. I've also done quite a bit of work on the problem of suffering and wounded healers. I'm not going to go into that here, but the problem of suffering is basically this. If you envisage an all-powerful God and a loving God, why doesn't that loving God use God's power to prevent the death of young babies? You know, who can't be blamed for anything. What's going on? It doesn't make sense. So the question I've asked is, does God have to be all-powerful and loving? Because it's the combination of those two that raises the sharpest questions. For example, could God be loving but not in control of the world, not all-powerful in that sense. Now, everything I've talked about so far has been what I call head stuff, academic, book stuff. For those of us in denominations where there's a strong sense of spirituality, there's another dimension to this, which is what I'm calling heart stuff. And I suspect that I'm a bit of a mystic and therefore have the problems that academics who are mystics often have. How do you reconcile the head stuff that I've just been talking about with the heart stuff and the sense of the spiritual that you also have? I don't have any answers here this afternoon, you will have noticed, but I've lots of questions. So I've had real trouble reconciling the head stuff and the heart stuff. I only recently come to understand that actually it's acceptable to have two different kinds of language, two different ways of thinking about things, that there doesn't have to be a single unified model. So I've got, I think, probably different languages. And where I am at the moment, and this may change, so, don't hold me to it forever, but where I am at the moment is, I do believe in a loving God, probably because I haven't got the guts to do without that. But if I'm going to believe in a loving God, I can't believe in an all-powerful God who's in control of the world because of the problem of suffering. I'm not sure whether God is unable to control the world or just chooses not to control the world. But for instance, I don't think it's sense to pray to God for good weather tomorrow so as we can all go out to the garden, or to help me pass an exam for which I haven't done enough work or whatever. And I've also come to the position that I don't believe God is a prime creator. Now, there's a certain amount of wriggle room in this creation of the universe. Scientists can tell you what was happening from very, very soon after the Big Bang. But they can't actually describe the Big Bang, and they certainly can't describe before the Big Bang. So there are people who would love me to say, God put it there, and God set up the laws of physics, and maybe lit the blue touch paper, and stood back while it went boom, and then the physicists can see the rest of it happen. I understand what those people want, but I am resisting it, because it feels to me a bit like a God of the gaps, which may be familiar to some of you, but not everybody. In earlier times, when our science was much less complete, and people were trying to work out how things came about, they'd understand so much, and then there was a gap. And they could see that if they could bridge that gap, they could understand the next bit, and maybe there was another gap. And what they did is they said, God did that bit. So we understand this, then God did this mysterious bit of the process, then the process has continued, and maybe God did that bit. But as scientific knowledge grew, the gap disappeared, and God was out of a job. That makes me profoundly uncomfortable, and I don't want to be saying, God put it there, just in case one day our science can prove that there's a perfectly understandable thing going on. So I resist the idea that God was the prime creator, although accepting that we scientists haven't got all the answers yet. I believe in a loving God because of the experiences I've had primarily through Quaker activities, and not least through Quaker activities in community, Quaker meeting for worship and things like that. I am left with a sense of a loving God. Now, maybe all here, and neurobiologists are getting very confident these days, and they're saying, yeah, it's all here. Well, okay, I'll live with that. We'll see. And this kind of response I make to that sense is an intuitive response rather than a logical one. But it seems to have served me well. It leads to me in a Quaker meeting for worship, sitting silent, sitting still. I sense that the questions, like the questions I've been tussling with over the last few minutes, become totally unimportant in a good Quaker meeting for worship. They just float away. They're not relevant. It's being here, sitting here in what I call the presence. And it often goes beyond words, and it sometimes goes to a stage where just your breathing is your prayer, your communion. And sometimes I have been powerfully prompted to speak in a Quaker meeting without understanding why on earth, only at the end of the meeting to discover exactly why and who that message was intended for. And it's quite a shaky experience. I think Walt Whitman summarises some nice things in his poem Sea Drift. A vast similitude interlocks all distances of space, however wide, all distances of time, all souls, all living bodies, though they be ever so different, all nations, all identities that have existed or may exist, all lives and deaths, all the past, present, future. The vast similitude spans them, and always has spanned, and shall forever span them, and shall compactly hold them. And a nice little quote from an Australian, Michael Lernig. Love is born with a dark and troubled face when hope is dead. And in the most unlikely place, love is born. Love is always born. So my science and my Quakerism have been Bedfellows since I was a teenager. And they are comfortable Bedfellows, but let's just look at the shape of those Bedfellows. The science Bedfellow is fine, thank you. The Quaker Bedfellow has adjusted to the shape of the science Bedfellow. My science has influenced my theology. I don't think my theology has influenced my science. One iota. Thank you for your interest.